All right. How are you guys doing this afternoon or this evening, depending on where you are? So let me talk a little bit about chapter 6, association of variables. So chapter 6 is kind of a shorter chapter, but it's still an important chapter. But let me talk about two questions I have. Question number one I want to talk about is cross-tabulation. A cross-tabulation shows that individuals with higher education levels have lower recidivism rates. If you were to take steps, what steps would you take before concluding that education reduces recidivism? And by recidivism, I'm referring to prison or jail recidivism. What role does the concept of control play in crosstab analysis? So that's one discussion question. Second question, Second question is scatterplots. Scatterplots are described as a tool for visually exploring relationships between variables. What features of a scatterplot might signal that a bivariate regression model would be inappropriate for the data even before running any analysis? So that's two very short discussion questions I want to talk about. Now, question number one, to go back to it, is a cross-tabulation shows that individuals with higher education levels have lower recidivism rates, which probably would make sense to a lot of people, right? It's very rare, when I did my research in prisons and prisoner reentry programs, Christian faith and non-faith based, 218 men I interviewed and conducted quantitative surveys with. I think only maybe two people, or maybe one, had a college degree. Everybody else actually stopped at 8th grade, or maybe completed high school, or a little bit of college, but that was it. So higher education levels, they do make a big difference, which probably makes some sense to people, right? Because if you have a bachelor's degree, you probably have better job opportunities than if someone did not have a bachelor's degree. Now, I would consider whether the relationship is counterfeit. Other factors could explain both education and recidivism. This is something that's not taught as much, and I wish it was taught more to students, that to question everything, to question why. Don't just operate on hypotheses because Professor Mini Chocolate Bar told you to do that. Ask questions about that. Now, other factors like age, income, employment, or prior criminal history may influence both education level and the likelihood of reoffending. Second, I would check the direction of causality. It is possible that people who are less likely to reoffend are also more likely to pursue education. It could be, and many of you may know people like that. When I did my research in Florida, there were people who had gotten out of jail or prison and they wanted to go back to school and they wanted to get some degree, whatever the degree was. There's so many things, but then it becomes limited because if you have a record, there's a lot of professions you can't get into. For example, like some states don't allow you to become a cosmetologist. Some states don't allow you to become a locksmith. Some states do not allow you to become a real estate agent. So once you go to prison or jail and you have something on your record, it limits you. It limits your job opportunities by a lot, which therefore, of course, limits, in some ways, it actually limits your lifespan in many ways. Because, of course, you may not get married, you may not have kids, you may end up doing a lot of drugs or drinking, you may fall in with a bad crowd, all of which significantly could reduce your life expectancy because you're not taking care of yourself, actually. After all of this, the third part of it would be I would examine whether the relationship is consistent across different groups and samples. If the pattern appears in multiple contexts, confidence in the relationship then increases. After all of that, I would then, as the researcher, I would consider using additional methods, such as multivariate analysis, to evaluate the relationship more carefully. Now, the concept of control plays a role in crosstab analysis. The concept of control plays a role in crosstab analysis. Control means holding other variables constant to see whether the relationship between two variables remains. In a crosstab, this is done by introducing a third variable and examining the relationship within categories of that variable. For example, I could control for age by looking at education and recidivism separately for younger and older individuals. If the relationship remains similar across the groups, it's then suggested a more direct relationship. If it disappears or changes, it suggests that the original relationship was influenced by the control variable. Control helps researchers move from simple association towards stronger evidence about relationship between variables. So, that should answer question number 1. Question 2, scatterplots. Scatterplots are described as a tool for visually exploring relationships between variables. What features of a scatterplot might signal that a bivariate regression model would be inappropriate for the data even before you run any analysis? Discuss. Now, scatterplots find extensive application to exploratory data analysis in order to visually examine the relation between two variables before attempting to have a statistical model. According to Jenkins Smith, our textbook, they enable the researcher to see patterns, densities, and possible associations in a geometrical space. Nevertheless, a close examination of a scatterplot might also bring out aspects that suggest the use of a simple bivariate regression model would not be suitable even before formal estimation is done. So, nonlinearity is one of the major features. The bivariate linear regression is used when there is a straight line relationship between the independent and dependent variables. When the points in a scatterplot have a curved U-shaped or otherwise nonlinear appearance, this is an indication that they would not suggest a linear relationship. A linear relationship, of course, means point A to point B in a straight line. Time is a very good example, and many times you watch a lot of sci-fi movies, like your professor enjoys sci-fi movies very much. They talk about that. Some of you remember a really great movie in the 80s called Back to the Future. It made three of them, Back to the Future 1, 2, and 3. I have seen all three many times. I highly advise students to watch that movie. It's a very enjoyable 80s movie. It's got Michael J. Fox, so you can't go wrong with him. That movie, he has to go back and forth between time. And the professor explains to him that time can become nonlinear, meaning you can go back and forth and jump in time. But time is supposed to be linear. It's 9 o'clock in the morning, then 10 o'clock, then 11 o'clock. It's a linear straight line. It has to move in a certain direction. Of course, if you're in Hollywood, time can go backwards also, and that's perfectly okay, because that's what makes a movie so great. And it's got a very cool car in it, the DeLorean, which actually no longer exists, which is another story for another day, so that your professor should move on. Now, a locally weighted scatterplot smoothing curve can deviate significantly away from the fitted regression line, indicating that a nonlinear model or transformation would be more suited in such a situation. Heteroacidicity or variance of errors that are uneven is another significant indicator. Under well-specified linear regression, the dispersion of points along the regression line should be comparatively uniform along all the values of the independent variable. When the scatter plot indicates a funnel or a situation where the variability is growing or declining in a systematic way. Along the x-axis, this is a failure to one of the major assumptions of ordinary least squares regression, OLS. Now, these trends then indicate that standard errors could be biased, and it might be required to use other modeling approaches like weighted regression or variable transformation. Subgroups or clusters in the data are also alarming. In case the scatter plot has observable groupings of observations, it can denote that there may be omitted categorical variables or interaction effect. As an example, a weak overall relationship may conceal strong relationship between subgroups. In this case, the existence of just one bivariate regression line would be used to mask any meaningful heterogeneity in that data structure. Another important characteristic is the existence of an outlier and influential points. Scatterplots are simple to determine the observations that are far and away from the overall trend. These points may have a disproportionate effect on the regression line, estimated which may distort the results. A simple regression model might not be an accurate summary of the data in the event that a few extreme observations seem to be driving the apparent relationship. Now, also the absence of any observable pattern can be an indicator that regression is not suitable. In the case of randomly distributed points with no conspicuous trend, the regression line can be fitted, giving statistically insignificant or substantially meaningless findings. According to the author, only visual inspections may be incorrect in some cases, whereas the lack of the structure of the scatter plot remains a significant initial clue that there is no significant association between two elements. Lastly, a bivariate regression might be restricted by the discreteness of data and overplotting. When variables assume only a small number of discrete values, the points can be superimposed, making the actual distribution obscure. Though methods like jittering may mitigate this problem, even the underlying discreteness can break assumptions on continuity and linearity. Overall, the significance, to close up this question, overall the significance of scatterplots offers important diagnostic background prior to the estimation of models. So you should really think about scatterplots clearly enough before you introduce your models. Nonlinearity, heteroscedasticity, clustering, outliers, absence of pattern, and discreteness are features which all indicate that even a simple bivariate regression model might not be suitable or adequate. Visual inspection with substantive reasoning assists in ensuring that the further statistical modeling is correct and informative. So, excuse me, I hope that was a good, clear explanation of the two questions, excuse me, that I asked. Pardon my voice. And I hope that you were able to get a few mini candy bars of knowledge, again, for you guys. I want to see you guys again in Chapter 7. Thank you for your time. Have a wonderful day or a night, wherever you may be.